Welcome back to Infinity Beyond. We've felt time in our bones, seen it stretch near black holes, and watched it speed up in our memories. But now, we're ready to ask the big question, the one that has fueled countless science fiction stories and late-night thoughts. Is time travel possible? It sounds like fantasy, but science actually has a lot to say on the topic. Let's start by understanding what time travel really means. We all move forward in time, 1 second per second. That's just existence. But the dream is to move faster or slower, or backward. The most scientifically grounded theory of time travel comes from Einstein's theory of relativity. We've discussed how time slows down the faster you move. This has been confirmed with satellites and atomic clocks. If you could travel at 99.999 the speed of light and return to Earth, you might age just a few days, while decades pass for everyone else. That's called time dilation, and it's real. In a sense, this is forward time travel, using speed to cheat the clock. But what about going backward? That's where things get weird and controversial. One idea comes from the concept of wormholes, theoretical tunnels in space-time that could connect two distant points. If wormholes exist, and if one end could be accelerated to near-light speed and then brought back, you'd have a time difference between the two ends. Step into one and emerge in the past or future. It's a mind-bending idea supported by Einstein's equations, though no physical wormhole has ever been discovered. There's also the notion of closed timelike curves, CTCs, solutions to Einstein's field equations that allow for loops in time. These could theoretically let an object return to its own past. But CTCs introduce serious problems. Paradoxes. The most famous is the grandfather paradox. Imagine you travel back in time and prevent your grandfather from meeting your grandmother. Then you'd never be born, which means you couldn't have traveled back to prevent the meeting. Logical loops like this are a huge problem for backward time travel. To resolve this, physicist Kip Thorne and others have proposed self-consistency principles. These suggest that events in a time loop must always be consistent. You can't change the past, only fulfill it. You might try to stop your grandfather, but fail in a way that ensures your own birth. In this view, time is flexible, but not rewritable. Quantum physics offers a slightly different view. The many worlds interpretation suggests that every possible outcome of a quantum event actually occurs in a different, parallel universe. So, if you went back and changed the past, you'd simply create a new timeline. Your original timeline remains intact, and no paradox arises. This theory inspired countless sci-fi works, from Marvel's multiverse to Back to the Future. It's thrilling but speculative. We have no experimental evidence of parallel timelines or alternate realities. Still, some physicists believe time travel may be possible, just not practical. The energy required to create a stable wormhole or manipulate space-time is far beyond our current capabilities. We'd need something called negative energy, which might exist in tiny quantum fluctuations but has never been harnessed in bulk. Even if we had the technology, the risks are enormous. Wormholes might collapse instantly. Traveling faster than light could break causality. And quantum instability could erase entire timelines. But let's not give up hope just yet. There's another fascinating concept called the tachyon, a hypothetical particle that always moves faster than light. If tachyons exist, they could carry information backward in time. But so far, they remain purely theoretical. Some scientists think the key lies not in brute force, but in understanding time itself more deeply. Maybe time travel isn't about machines and tunnels, but about perception, entanglement, or undiscovered dimensions. And here's the twist. In a way, we are all time travelers already. We remember the past. We imagine the future. We carry our stories across decades. Our minds are bridges through time, creating meaning out of sequence. Einstein once said, "The distinction between past, present, and future is only a stubbornly persistent illusion." Maybe time travel isn't about breaking the rules of physics, but about understanding the illusions we live within. So, is time travel possible? Forward? Yes, via speed, gravity, and relativity. Backward? Maybe, in theory, with paradoxes, exotic matter, or multiverses. Practically? Not yet, but our understanding is still growing. And that's what makes science beautiful. Every question leads to more mystery. Every breakthrough opens new doors. Time, like the universe, is still unfolding. In our next segment, we'll explore a timeless topic in a different sense: the philosophy of time. Is the past gone? Is the future real? What do great thinkers, Plato, Kant, and modern philosophers, say about time's meaning? But for now, thank you for journeying through the science of time travel with us. Even if we never step into a machine like in the movies, we've already traveled far, together.